exciting day today. Today we're going to make a vlog, a MoMac vlog. We're going to go behind the scenes and we're going to take you with us to Rodin Cars where they're hosting a sponsored Drivers Day. So today is all about inviting some of the guests along and some of the drivers and have a little bit of fun, show people around the facility and a little bit of meet and greet. So we're here in Culverden. We've got our guests travelling with us today in the MoMac wagon, Ollie on the camera, and we've also just met up with Liam and Hannah here in Culverden, quick coffee, and we're about to head up, so see you soon. So we've just arrived at Rodin Cars, we've signed in, we've met some of the guests, and as you can see behind me, the tour has kicked off, so for now we're just having a wee look around the production facility and learning more about the machine. Okay, so today we're here with Mike. Mike is from Rodin Cars. Mike is the CNC machinist and is also leading the tour for today. So Mike is going to give us a quick little tour around some of the machining, just give you a little overview of what things do. So Mike, this machine behind us, What does it do?
So this is our foundry where we do the investment casting of the cylinder heads, cylinder blocks, rocker covers, various stages of the oil pump. So when we say we're building the engine from scratch, we're literally melting down the material, pouring it into a mold and then getting the end product.
This incredible machine behind us, can you tell us what this is and what it does?
Yeah, sure. So this is our ion heat treatment machine for doing all the surface hardening and stress relieving of our internal parts of the engine, so things like the camshaft, crankshaft, that sort of stuff. And we've also got our two PVD machines that do physical vapor deposition of titanium nitrate, and this one over here can also do diamond-like coating, so DLC. That's really good for all the hard-wearing bearing surfaces.
And one of the cool things about this machine is the gold plating. Can you give us a little example? Can you show us something?
Yeah, for sure. Come over here. So this is a titanium 3D printed suspension component. So base material is titanium and then it's coated in the gold coating, which is titanium nitrate. Similar to what you'll find on all your high-speed steel drill bits and stuff, but we really do it just because it looks cool. It's really good for corrosion resistance and also adds a little bit of wear resistance as well.
Okay, so now Mike's going to take us through some of the 3D printers. Mike, tell us about this first one.
So this is our workhorse, the HP Fusion Jet machine. So we do a lot of rapid prototyping on this, as well as printing some stuff for the interior of the car. One of the cool things about this machine is you can do really intricate shapes and it's all print in place, no support. You literally take it out the machine, get rid of all the excess powder, and we choose to dye it black just so it stays a little bit cleaner. How this machine works is you've got a build chamber full of nylon powder. It's heated up just to below the melting temperature of the material, and then there's a little inkjet that comes over the top and sprays a black binding agent right where you want it for the part. With it being black, it absorbs that little bit extra temperature and fuses together. And I'll do that layer by layer until you get to your finished part.
Mike, this 3D printer behind us is incredible. It's ginormous. Can you tell us a little bit about it?
Yeah, so this is a massive titanium 3D printer. So it's the DMP Factory 500 from 3D Systems. This machine is pretty much the workhorse for doing all our big components like gearbox case, suspension uprights, and other massive pieces. So it works by having 3 lasers weld titanium powder together on a build plate, which happens under vacuum with an argon purge. It does it layer by layer at about 20 to 50 micron layers and generates the part like that.
Cool, and this 3D printer is one of the largest in the Southern Hemisphere, is that right?
Yes, that's correct. Yeah, so 500 cubic millimeters. It's pretty beastie.
Cool. And something like this, what is this worth?
I think the investment for this machine, you're looking somewhere around $6 million. This is our machining department. We've got the bigger lathes and mills. This here is a 9-axis Doosan Puma. So this machine is going to be, is currently machining a bunch of crankshafts for the RC10 V10. So it's got 9 axes, so you've got live spindles each side. It's got this hydraulic steady rest, number of tools there, and then you've got a 5-axis head up there as well. So you can pretty much reach any angle and machine anything you want on this machine. We also do the camshafts, which are hollow. So there's some gun drilling in that as well.
And so this machine here, predominantly crankshafts and camshafts?
Yeah, that's correct.
Cool. And size-wise, is this size pretty common in New Zealand, or is it one of the bigger ones?
This is definitely one of the bigger machines, yeah.
Cool. And the investment on this sort of machine, do you know?
I think it's around $700,000-800,000, and that's without all the tooling. And like, for example, there's some drills in here that are $1,200 each, and I believe this has an 80 tool magazine, so there's a lot of investment in that too. CNC turning department, where more of the round bits, a lot of fasteners get made in this area. So on this machine specifically, we've got it set up for full automation. So we've got a bar feeder that loads the machine with material. Once you've got your program all sorted, various tools machine the part. You can do operation 1, then this spindle will come over, grab it, and you can do operation 2 on the other side. So this bolt example.
Yeah, so the type of detail that we're talking at Rodin is making your own bolts.
Yeah.
Every single nut bolt on the cars is manufactured in-house.
They're all custom sized. Some of them have custom threads as well for the engineering needs. But yeah, one of the other cool things on this machine is it's got a little parts catcher. So once the part's done, it'll eject it into the parts catcher and then spit it out onto this little conveyor belt there. So yeah, a few hours time you could have 50 to 100 bolts.
And this is just an example of some of the bolts that it's produced.
You can do things really quickly. So we broke one of these on the FZ and we had to machine one up relatively quickly. So this was programmed and machined in under 2 hours in one operation. So it's pretty cool. So this is the EDM wire cutting department. Predominantly these machines are used for removing metal prints off the build plate. So over here you can see an uncompleted print of some brake calipers. So what happens is this plate is off the factory 500. You mount it at 90 degrees parallel to the wire. The whole system fills up with deionized water, which is non-conductive, and then the wire is charged as it passes across like 2 or 3 mil off the plate, and a little spark jumps between the material and the wire and erodes it away until your part's cut off.
What is this component here?
So this is actually a failed print, but this was going to be 3D printed 6-piston brake calipers.
Yep.
And I believe this one failed due to a power cut, which is something we can't really control.
And the likelihood of something failing in the 3D printer?
If you've got all your settings dialed, it's pretty good. But a lot of the stuff we do is research and development, so we do have our fair share of issues, but we get on top of them pretty quickly.
Nice. And this is one of the plates out of the big 3D printers?
Yeah. So that's quite a chunky piece. I think it's about 50 mil.
And the weight of that plate?
Not sure on the weight, but I know
Heavy.
they're a couple grand, yeah.
Okay, so Mike, can you tell us about this room and what everybody does in here?
So this is our design office where a lot of the engineering and design team work. So we use NX and SolidWorks for designing all our parts and doing different types of analysis. So everyone's got their own little area, and that's divided up into different departments like powertrain, structures, chassis, suspension, all that sort of stuff.
So the first part of the Sponsored Drivers Day was a quick little tour inside the production facility. Mike, thanks very much for showing us through. Where are we heading to next?
Next we're going to be heading to the assembly shed where we've got the F0 on display as well as the FZ. So we'll go have a look.
Cool, let's do it.
Awesome.
Mike, we've just come from the production facility. We're now standing in the assembly shed. Can you tell us what this is all about?
So this is where we piece together the FZ and the F0 as well as storing all of our inventory of spare parts for the cars. But in front of us is the Rodin FZ. So this runs a 3.8 litre Cosworth GPV8. It's about 675 horsepower and the whole thing only weighs 609 kilos with a full tank of 98. So a lot of the parts on this car have been developed in-house, like all the suspension, rockers and pivots. All the nuts and bolts are machined in-house out of titanium. The real nice showpiece is the steering wheel. So that's all made from 3D printed titanium. We've got a bit of composite there as the surround. The whole way the interface works is done in-house. Obviously you've got your pedals for changing gears and a hand clutch. And then you've got the quick release, so you take the steering wheel off when the driver's getting in and out the car.
Awesome. And something pretty exciting, pretty special in the background, the F0. Let's go have a look. So the F0, this is David Dicker's brainchild, and it's finally, basically complete.
Come to fruition.
In its raw format. Can you tell us a little bit about it?
So this is something everyone in the team at Rodin's been working quite hard on. We've finally done the first few test laps on it. It runs a 4-litre twin-turbo V10 that's fully developed in-house to David's specifications. So this is designed to have about 4 tonne of downforce at top speed and do around 360 to 400 kilometres an hour depending on the gearing.
So the Rodin team must be super proud of both the FZ and the F-Zero. The assembly shed is where everything comes together. Let's go have a look at something else. Where are we going to next?
We'll go to composites shed.
Okay, so we're now standing in the composites room. Mike, can you tell us what it's all about?
So this is a composites clean room where a lot or almost all of the pre-preg carbon fibre lamination happens. So behind me we've got a 3-axis CNC plot cutter for cutting out all the different shapes that go into the laminate. We've also got some different consumable materials here for making the vacuum bags, and there's a few parts scattered around on the table that you could have a look at as well.
And it does feel very cool in here. What's the reason for that?
So the resin starts going off at just over room temperature. So while we're working with the material, we don't want that chemical process to start happening. So everything needs to stay nice and cool while we're putting the different layers of the lamination into the bark mold.
Okay, so we've now finished up in here. We're going to head over to the pit shed, and on the way over, we're going to have a little drive around the track. Let's go check it out.
Awesome, let's go.
Okay, Mike, so we're here in the pit garage. Behind us, we have a couple of cars. There's some of David's, his Ferrari and the McLaren, but we've also got the FZ in the background. But the pit garage, what is the purpose of the pit garage at Rodin Cars?
So in here, this is usually where we start and finish the cars off. So cars like the FZ, we have to run an engine preheater, so it gets the engine up to temperature before you actually start it, because everything's actually an interference fit until it's up to temperature, so it actually won't turn over. So once that's all done, we get the driver seated in, do a few tests, and then off you go. Do a few laps, and then you can come back in. So got doors on both sides. And other than that, we've got some built-in hoists in the floor that'll actually lift the whole car up from the floor pan, change the tyres, do suspension adjustments and stuff like that.
And so the pit garage, the facility is also for owners who buy vehicles and in between going out and driving laps around the track.
For sure. And yeah, we've also got a full TV screen in there and the nice air-conditioned lounge where they can sort of break down the track into its different sections and see where they need to improve or just change their sort of method to going around the track. And we have a driver trainer here for that as well.
Okay, Mike, what do we have up here? What is this screen?
So up here we've got our display for the transponders. So there's a little programmable device that you attach to the front bumper of the car, and it goes past the start-finish point on the track and records your lap times. And then there's live display up here, so you can do a few laps, come in, check your lap time, and then carry on. Yeah.
Okay, Mike, we see these loud things, these blowers.
Yeah.
What do they do? What's their purpose?
So this is just a modified leaf blower, but obviously once the car's been out on track for a bit, it's pretty hot, so we want to get it to cool down as quickly as possible when it comes in. So car comes in, as soon as the power's down, chuck these in here. And it's cooling everything down. So the radiators are in these side pods on each side. Yeah.
So unlike a conventional car on the road, there is no fan in these. Cool. So they do rely on the wind or the air passing through. So Mike, all these tyres, where are we and what is this all for?
So we're in the tyre shed down at the pit bay, and obviously these are all David's various cars, as well as some of the, when the test drivers come, we always want to give them an even chance, so they'll start with a fresh set of tyres, but got everything from hard compound to super soft like these ones over here. Got some really, really sticky ones. You can actually leave your fingerprint in the tyre. Yeah, we've just got to cater for all the different types of track positions, so that's why we've got so many tyres.